Okay, so today I'm going to go through how to use a Google Spreadsheet in order to input some data, do a few functions with it, and to create some charts. Okay, so first I'm going to go to Create. I'm going to do a new spreadsheet, and the data that we're looking at for this spreadsheet involved measuring the mass of 1 penny, then extrapolating the mass of 1 penny to 10, 25, and 50 pennies, including propagating the error for that, and then actually measuring those values and comparing how the extrapolated values compared with the actual measured values. So we'll start like this by setting up our charts. Okay, so we've got number of pennies, predicted mass, propagated uncertainty, percent uncertainty. We'll see why we do that in a little bit here. Measured mass, the scale that we used for measured mass was plus or minus 0.05 grams. This is based on the scale that we used. And then the last thing would be a percent error when we compare our predicted mass to our actual measured mass. So there's the headings that we want. 1 penny that was actually measured, 10 pennies, 25 pennies, and 50 pennies. Okay, we didn't predict this mass because we actually measured it, so it's not applicable. Okay, and the actual measured mass of the penny was 2.41 grams, and there's not going to be a percent error on that. Okay, now one thing to notice is if the program is recognizing the value as a number, it's going to align on the right side. If it recognizes it as words, it's going to left align. Okay, you want it to be right aligned if it's a number, so you can't do things like put your units right in here. If I do that, it recognizes it as being a word, which is no good because you can't make a graph or a chart if there's words in there. Okay, now I'm just going to quickly fill in the data, so just bear with me for a second here. So basically these values are taking that 2.41 and just multiplying forward for how much would 10 weigh then, how much would 25 weigh, and how much would 50 weigh. There is uncertainty associated with that. So this was propagated by the person doing the lab. Alright, and basically it's taking that 0.05 grams uncertainty on the original measurement and bringing it forward for 10 times, so you can have 10 times more error, 25 times, and 50 times more, I should say, uncertainty. Okay. One thing I forgot here was to put our units. You always have to put your units. It's grams, and this is plus or minus that number of grams. Okay, so there we go. Now the percent uncertainty is going to be this value here divided by this value multiplied by 100. The program will actually take your decimal and turn it into a percentage. So let's see how we do that. Now I'm going to enter a formula. So I'm going to hit equals. I'll zoom in a bit here. I'm going to hit equals. Okay, so now the computer is going to recognize that as the entry of a formula. What I want is to take this cell, so I just click it. Notice it says cell C4, C4. I'm going to divide that by the next cell over. I'm going to hit enter. It's going to give me that value in terms of a decimal. Quick shortcut here, highlight this, hold the shift key and press the down arrow twice. Okay, and if you hit Control D, as in down, Control D, it brings your formula down. If you take a look, what it's also done is it's adjusted the formula to be for the correct cells. Okay, and there's ways to make it stay on one cell or to actually bring the cells forward. We want them to be brought forward. Now this doesn't look like a percentage, so we're going to format these cells again, hold shift and down to highlight them. You can also hold shift and click, and that brings it all the way down too. Okay, and then we're going to go to the Format button. We're going to format the numbers in these cells, and we're going to go to a percent. And there we go. So 2.07% error on each of these measurements. Okay, and as you propagate error, if you do it properly, the percent error should always stay the same. There's 2.07% error on this, and therefore as you bring it forward, that percent error stays the same even though our values get larger. Now we'll put in our measured masses, so the person actually took these numbers of pennies, put them on the scale, and these are the values that were obtained from that. Notice they don't necessarily exactly match the predicted values. They're close, but they're not quite right. And that's to be expected considering how the lab was done. Okay, and notice that the percentage uncertainty associated with the scale is put up here. We don't want to put that in here because it won't recognize it again as a number. Okay, all of these are recognized as a number, and that's good. That's what we want. Okay, so percent error now. This is the predicted value, so the actual value, subtract the predicted value divided by the actual value, and then times 100. So we're going to use a formula again for that. So what we want to do is we want to take the actual value, and we want the absolute value of it. So you're going to go ABS. Okay, this gives you the absolute value of the number, bracket. Okay, so we want the absolute value of what happens when we take the actual mass minus the predicted mass divided by the actual mass, and we're going to hit enter. It's going to give us a decimal again. That's what we want. I'm going to Control D to fill that down, and then I'm going to format that data as a percentage. Okay, there we go. So that's all the math that we need to do for this particular part of the lab. We also need to make our chart look a lot prettier. Okay, so now I'm going to format this chart to my liking. So I want a border around it. I want a black border, and I want it solid, and I want it around everything. I also want interior borders, but I want them to be red. This is just my personal choice, and that looks pretty good. Then I want to take this top header here, and I want to put a background color on it. So I click on this background thing. We'll go with a gray color. Okay, so that's pretty good looking. Maybe I'll just border this up so we can tell that it's part of the heading and not part of anything else. And interior it, and there we go. All right, pretty good looking data. Now I'm going to align it all. So highlight what I want. I'm going to click on here, align. Pretty obvious what that means. I want to center everything, and I also want to center it in its cell. And there we go. Really pretty data. All right. In the second podcast, we're going to come back and we're going to put this into a chart. Okay, thanks very much.